bit ahead of ourselves here. Listen, let me start off with this. 24 February 2022, Russia invaded, as we all know, their former client state of Ukraine. All military experts, virtually all, said that Russia would seize Kyiv within days or a week. 393 days later, virtually all military experts were wrong. Why? Well, there's a lot of things you could talk about. You could talk about tactics, will to fight, leadership, any number of things. But any serious analysis of the challenges that Russia has had in Ukraine all comes back to one word: hubris. Hubris as it relates to a nation's ability to sustain expeditionary ops into a foreign country or a foreign region. Now you might ask, okay, this is ARPA-E, this is Department of Energy. Why is Wesley starting out with an analysis of the failures of Russia in Ukraine? I think there's a point to be made here. In May of last year, almost a year ago, the late David Johnson penned this article on War in the Rocks, and it goes to, would we do better? We should all ask that question in as much as, do we think, given our constraints, that we would not be facing the same challenges as it relates to sustainment of the battlefield, which all comes back to energy. Let me put a finer point on this. So the map on the left there shows the distances Russia would have to go in order to seize Kyiv. Actually, it shows the distances in the first days of the war that they sought to get after. Ultimately, it's about 100 to 200 miles. And they ground to a halt because they couldn't sustain that fight, among other things, with energy. Take a look at this. The U.S. and our partners and allies face a much bigger challenge, orders of magnitude, relative to what the Russians have had to endure in the current operating environment. So we should be very wary before we criticize what the Russians have tried to achieve and what we incur in terms of an obligation if we want to influence regions around the world on behalf of our national security interests. And if I were to put just a tight phrase on it, as provocative as that might seem, ladies and gentlemen, as it relates to Ukraine, the lens that we should look at this through, we are Russia. So with that as an opening teaser, and I hope I got your attention, ladies and gentlemen, I'm Eric Wesley. I'm happy to be here. This is an incredible forum. I was on the floor. There's some amazing technologies out there that just stuns my mind, and I'm happy to be a part of this. Just for context, my background, I was 38 years with the military. My last 5, I was charged with designing the future Army for all intents and purposes based on the future operating environment that we expect to go into. And I'll talk more about that in a minute. Now, just to reassure you, I am a recovering government employee as a soldier. I'm a CEO of a startup down in Austin, Texas, a tech startup, and so I feel some of the things that you've experienced and some of those in the audience, but so I've been on both sides of this. But Evelyn Wang asked me to come talk to you about this. You know, and by the way, I'm not a tech guy. I'm not a formal engineer. I'm not a technologist. I'm not a scientist. I'm a practitioner. And so what she asked me to do is talk about the lens of the military as it relates to the future and what technologies are critical as we go forward. What innovative things do we need to get after in order to enable our soldiers in order to deter in the future or, if necessary, fight and win? So what I'm going to do is I'm going to lay out for you very briefly, the description of the problem that we face with our peer competitors, Russia and China. And then I'll very briefly talk about how the big principles that we have to get after as it relates to energy for the United States military. And then I'm going to talk to you about 6 technologies that I think are critical in order to preclude the problems that Russia has faced. So let's talk about the problem. So in 2016, this is 2 years after Russia had entered Ukraine the first time, the Army chartered a study on what is going on and what is Russia doing. And it sort of mirrored a study that we did in 1973 after the Israeli war, where the Chief of Staff of the Army chartered a study. We called it the Starry Study after Brigadier General Starry. He went to Israel and he said, okay, because the satellites of Russia and Soviet Union had attacked into Israel and wanted to know what technologies was Russia using, and we produced the Starry Study. The Starry Study ultimately produced the warfighting concept that we've known for the last 30 years, and that's air-land battle. So in 2016, the New Generation Warfare Study was commissioned. And by the way, it says Russian, but ultimately we integrate it with the threats with China, and we found that there's some commonalities that we derived. And frankly, there were three things that struck us about what the Russians were doing and what the Chinese were doing. And the first is they were going to leverage the competition space in order to win before fighting. Now, I'm not going to spend a lot of time on that, but a lot of the things we see today, leveraging the competition space left of conflict, is something that both nations are pursuing. The second one is this idea that they are going to challenge us in all domains. Most of us in this room experienced Gulf War I, if not Gulf War II, and what you saw is the technology and capabilities across all domains: air, sea, land, space, cyber, et cetera. And the United States, our partners, allies, are very good at that. And what they did is they invested in things that could preclude us from using those technologies at will, using asymmetric counter technologies. So that's a concern. The last one I want to talk about really relates to energy. And I'll connect the dots in a minute. But the real issue is they wanted to establish multiple layers of standoff. Why? Because they watched us in 1991. They watched us in 2003, and what China and Russia learned is if you let the United States of America, her partners and allies, get into a theater of war unhindered, it doesn't end well. So they built in multiple layers of standoff to preclude us from getting there. So what does that include? Well, some of it is social media. We've seen a lot of talk about influence on the election with respect to social media. The other one is, for example, cyber attacks. If you remember the attack on the Colonial Pipeline as an example. So cyber attacks. But it also includes long-range, precision, massed fires. Exceedingly deadly at long ranges. That becomes a problem as it relates to energy. So it's this multiple layers of standoff that I'm going to focus on as it relates to energy in a moment. So after we published this New Generation Warfare Study, you take just like the Starry Study, we want to take it and, okay, so what does that mean for building a military? And what we did is we build multi-domain operations. Many of you have probably heard of MDO. It was an Army document. It's driving much of what the Department of Defense is doing in terms of how we want to fight in the future. And there are a number of first-order, I won't go through the whole document with you, but I do want to pull out some critical first-order principles as it relates to energy, and then I'll move into some key technologies. So let's take a look at the first one. Vulnerable supply chains. When I talk about long-range, precision, massed fires, and you look at that picture, pictures speak 1,000 words. That is a convoy of fuelers that is decimated by accurate long-range targeting. Now let's talk about fossil fuels and liquid fuel for a moment. Since the automotive revolution, you all know this, that we as a nation, we as a military, but worldwide, liquid fuel became the medium of choice for a lot of practical reasons. But it's exceedingly inefficient. If you consider the fact, and I'll come back to this later, when you talk about liquid fuel for an expeditionary force in a foreign land, it starts in, say, a state called Louisiana, a refinery, We bring fuel, oil, gas, put it on trucks or trains. It goes to a domestic port. It gets on a ship. It goes to a foreign port. It downloads. It gets on ships, trains, and then it goes to the user that needs it. That is an exceedingly inefficient approach to moving energy, right? And it's also very vulnerable. You've got a supply chain that, whether it's a colonial pipeline attack or something that's more tactical and near, that is really fundamental and very critical. The other thing is, when we talk about long-range precision mass fires, back in the day under air-land battle and other fights, we used to talk about the rear area. Everybody in this room probably can identify with the idea of a rear area. The rear area was always protected, and you can move logistics to the point of need in past wars. When you look at that picture, you know that that approach is problematic. So vulnerable supply chains is absolutely a critical problem in the future. Because of vulnerable supply chains, and this is a lift from the Marine Corps, by the way, but because of vulnerable supply chains, we've got to conduct distributed operations. First of all, consolidating a lot of logistics in one place puts you at great risk. Consolidating anything at one place creates great risk. So what you have to do is distribute your units so that you reduce the number of lucrative targets. Well, as an energy guy or gal, you're thinking about that and go, distributed is problematic because you've got to get energy to those locations, and you've got disparate locations. And so in order to resupply anything like that with energy is going to be a major problem. The distributed posture is about force protection. The distributed problem is about us. How do we get energy to distributed units? And then the final first-order principle I want to mention that came out of multi-domain operations is this idea of an energy gap. And I'm sure there's been chatter amongst this group on this, but when you think about in the last 20 or 30 years, the rate of increase of the demand for energy is exponential. Everything from digital systems that soldiers carry that require batteries upon batteries, computing requirements at command posts, UAVs that might be locally deployed, directed energy weapons, it goes on and on. So the demand for energy far exceeds anything we can get out of marginal gains with liquid fuel. So the energy gap has to be closed. And it's additive, not necessarily distinct. It's an additive demand. So these are the first order principles we talked through. And I'll just let you read that. But so your question might be, okay, what does that have to do with me? What do I get out of this myself, and what should I take away? I'm going to run through 6 technologies that we think are critical for the future. The first one is this idea of organic power generation. Why? Why organic power generation? Because I talked to you about the Louisiana supply chain. I picked Louisiana, but the bottom line is that is an inefficient way of moving energy. So how can we organically generate power at the point of need? Some of you have heard of a technology that we're developing in the Pentagon called Pele. It's intended to be a microreactor, 1 to 5 megawatt, that can be mobile. But it's not just Pele. There are startups out there that are looking to build microreactors that are safe with advanced technologies. This one in particular from a company called Radiant Nuclear, building Kaleidos. This goes in a shipping container, which can go anywhere. It can go on trucks, trains, and the C-17 aircraft. You're moving 1 megawatt of power to a point of need that can be generated there. That's the equivalent of 425 fuelers that you just saw burning on the previous slide. It's an order of 2 orders of magnitude, 110 to 1 in terms of energy density. That's a critical need right there. The idea of organic power generation, and I think nuclear power is critical. Now, some of you may or may not be integrated with the nuclear industry, but if you're wondering, it's now safe. And the idea that really makes it safer is the idea of TRISO fuel. TRISO fuel, and this is the second technology, by the way, I want to talk about, is something smaller than a piece of rice that encased in silicon carbide, where you take nuclear material, encase it in silicon carbide that only is destroyed at 1600 Celsius, but the reactor burns at 900. So it's literally meltdown proof. If it were to be destroyed in combat, all that happens is these little kernels float around, you vacuum them up. The proliferation problem doesn't exist. Now, why do I bring up TRISO fuel as a second technology? Because although it's been around for a while, there are two issues with the TRISO that we really need to get after. China right now produces 1.5 metric tons of TRISO fuel a year. Our production facility, which I think the ribbon was cut in December, is nascent. We've got to get after that. We've got to produce if we're going to get after this technology. Second, I showed you the startup called Radiant. We need to get access to this with startups. You know, we have a legacy mindset as it relates to nuclear fuel. This is much less refined, 19.75%, I think, in these little particles, and it's not a proliferation problem. So we need to get access to startups. Third technology is mobile energy storage, and this is important as it relates to nuclear power or any kind of electric power situation. I think we need to talk about getting energy storage out into a mobile tactical environment. We talked about energy storage on the opening comments on day one, all about energy storage domestically, but it's got to be mobile and tactical so that you can optimize the energy that we produce locally, in the case of Kaleidos or Radiant or Pele, so that you can optimize the grid, because when we plug into some kind of network in a foreign theater in an expeditionary manner, we don't have a stabilized grid to plug into. So energy storage, that is a problem I think that needs to be solved and is open for creativity. Carbon capture, synthetic fuel manufacturing. Making synthetic jet fuel. These two gentlemen have a startup called Air Company. They manufacture synthetic fuel. Now, why would we want to do that? Well, remember the supply chain I talked to you about. 7,000 miles, and you got to refuel jets. What if you manufactured fuel in the theater you were fighting in, Guam, et cetera? There are 20,000 islands in the South China Sea. Now, you say, well, that's a problem because energy in is greater than energy out. It's net negative. If you've got a nuclear reactor at 2 orders of magnitude energy density, now you've got something that generates that fuel, and you're building your own fuel. That's a technology that will help the operational problem I described. Wireless energy transmission and transfer. Now, this should be intuitive because we don't want those fuelers moving all over the battlefield if we can avoid it. Reach Power I just talked to them yesterday. It's a technology that allows you to move energy through the air. Now that's powerful because now I don't have to run, right now this is nascent technology, but they're moving 160 kilowatts across a kilometer at about 50% reduction in efficiency. Okay, that's problematic, but when you consider the amount of inefficiency of moving a gallon of gas from Louisiana to Taiwan, now we're talking efficiency because it's about 1,000 times worse in that case. So moving energy wirelessly, and you can see just from the graphic, you can intuitively pick up why that might be helpful to us. The last one I want to talk about is, and I got to get off the stage, but is this idea of electrification. A lot of talk about electric vehicles. My first message to you is, well, there's a company out in California, Flyer, that's building one of the most amazing off-road vehicles I've ever seen, but it's electrified. But one of the things we've learned is you can't take commercial off-the-shelf technology and just put it in a combat vehicle. It's got to be built differently because it's on a different mission profile. One of which, I'll just be very quick on, is if you've got a flat rack or skateboard technology battery system like in a Tesla, that if you have thermal runaway, as we all see in the news, that thing's going to burn all day long. This is a modular battery system that allows you to gracefully degrade. So if one module goes, the others can be protected and you can still operate the vehicle. That's the kind of thinking we need with a backplane that sort of modulates all of that. Advanced batteries, these are going to charge only so fast and they're going to last so long. Lithium is the way now, but solid state technology, ceramic batteries is something we really need to explore in order to get the risk level down, but you've got an 8-to-1 energy density change. And then, of course, tactical grids. This is a summary if you want to take a picture of those 6 that I just mentioned. And I want to close up. Here's my closing thoughts for you. 2 things. One is, my entire remarks, I never mentioned carbon emissions, never mentioned climate change. The good news is, all of the things I mentioned achieve that for you. Achieve mitigation of those problems. And I said publicly recently once, and I'll get the audience riled up a little bit, and you might tar and feather me, but if you're patient, you won't. I'm mildly interested in the economy when I'm, or rather the ecology, when I'm trying to build an army that can deter, fight, and win against our peer threats. But if every gallon of gas we burn produced 0 carbon emissions, I would still tell you that those are the 6 technologies we need. And that's the good news. So you have a symbiotic relationship between climate change and carbon emission reduction and operational requirements that allow us to fight and win in the future. And then the last thing I'll share with you is thank you to all the innovators and thinkers out there, because the Army and the military at large need your help. I am indebted to all the creative thinkers here for not only what you've done in the past, but for what you will do in the future to continue to sustain our way of life. So with that, I'm going to finish up and get off the stage. God bless you. I'm going to be back in the foyer if anybody wants to talk further about these things. And then with that, go Army, beat Navy. Thank you.